All hands and arms inside the vehicle. You guys ready to go?
Yeah.
All right, so boop, 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 and boop. Question: how are we to, wait, what does evaluate mean in math? Evaluate means to T-proof. Nope. Rewrite? Nope. What does evaluate mean?
To solve.
Solve. Well, how am I supposed to, oh. Hey, PEMDAS would tell me to do what first, right here, guys, in this expression? PEMDAS says to?
Subtract.
Yeah, subtract. I can't subtract unless I get some like terms. What am I doing when I rewrite pi over 3 as 2 pi over 6? P.S. This is probably where your homework 5.4, 5.5 after the formula fills in, like, I don't know, number 7 starts. Question. How did I get one to be the other? How did I get pi over 3 to be 2 pi over 6? Tell me the magic. It's not magic, it's math. What'd I do?
Well, if you simplify 2 over 6, that's the same thing.
True, so we can see backwards why it works, and you're exactly right. So how do we go forwards? How could you have done the exact same thing, which is going to be so helpful in just a second?
Multiply by 2.
Multiply top and bottom by 2, and what is that process called? You are getting a common denominator. Then you can say 7 pi over 6 minus 2 pi over 6 becomes what, everybody? Come on. It's a subtraction. 5 pi over 6. Oh my goodness, is that a unit circle value?
Yes.
Probably. Oh dear. Yes. Yes, it is. If you ever have any doubts, you can say sixths are sixths of 180 special. 180 divided by 6. What's 18 divided by 6, cool kids? 30. Is a 30 an important thing in geometry? Yes, it's a pi over 6. So where would 5 of these 30s be? Where would 5 of these pi over 6s be?
Right before.
Right before the 180, because it's the same thing as 150 degrees, right? 5 of those 30s, that's 150, or 5 of those 5/6 of that pi is almost the whole calzone. Anybody having flashbacks of calzone goodness? If not, do your bonus. All right, so coming back. Sine of this location. Sine of this location is sine opposite or is sine adjacent? Opposite. Is the opposite little or is the opposite big? Little. So therefore, it is equal to, anybody have it before I say it? What's the little one?
Degrees.
What's the little value of sine?
30.
What's the little value of sine?
3 over 2.
That's the big one. What's the little one?
1/2.
1/2. Or cheater chart, people. Isn't this the very first angle you come to in the first quadrant? And sine is 1, 2, 3. It's the very first one. Boop-a-doop-a-doop.
I need a cheater chart.
Cheater chart is a great thing. Because that's the root 2. That happens in the middle. That's a pi over 4. Root 3 over 2. That happens at the top. And that's pi over 3. Just the negatives and the positives. Well, the negatives change it maybe in different quadrants. Right.
So it wouldn't be like any weird, like plus 2 pi n.
Not for this one, because you're simply evaluating what is sine here. Sine of here is, and why are you doing this? You might not know yet, but you're about to find out when we cover this one over here. So Noah and Caleb, we still good? We're evaluating another one, and the other one that we're evaluating, hold on. I do not have parentheses. I think I'm just supposed to go. You guys agree? Sine of 7 pi over 6. That is going to be in the third quadrant, and the third quadrant has the exact same opposite, but it's down. That's a negative 1/2. Minus, hey, what's sine of pi over 3? What's that of the big one? What would sine be at pi over 3? 1/3 of a calzone. Square root of 3 over 2. Hold on. If I was to put this together, that'd be negative 1 minus rad 3. I don't know. They have common denominators, don't they? Why did section 5.4 and 5.5 just have me answering unit circle questions? Look at the screen and look at the two problems together.
They're the same thing.
You would think they're the same thing, but are they?
No.
Absolutely not. So what are they reminding you does not happen in trig? Exactly. And what was one of the most important things that I said about all of section 5.4? I know there are all of these formulas, but what does trig never do? Because it's not multiplication. It's not sign times. It's sign of. Which is the same reason I don't distribute an ln if there's like a plus or minus inside. I don't distribute a square root if there's plus or minus underneath it. I don't distribute an e to the... Actually, that's all different because of exponent properties. But anyway, it's still not called distribution. Because of does not mean times. And I've been battling it since chapter 1. Because it's a natural inclination for you guys to be like, it's times! And like Ryan said, wouldn't you think those are the same? Take the sin and just let's move sin everywhere. Oh, let's not move sin everywhere, number 1. And number 2, well, because if you're taking this and distributing, you're like, it's sin times. And you're like, yay, sin times everything. Okay, there's maybe a life, we can talk about that. But back here, no, it's not sin. Ever since you asked somebody once upon a time, what's the sin button? It's not sin. What did that person tell you? What am I telling you now? It's what? Sign. And it's not sign times, it's sign of. And this is talking about an angle measure, and I just proved it to you that sign does not distribute. How do I do that then if I needed to? Well, hold on. Do you see this example we did last time? This example we did last time, our goal, our objective, well, I only did 1 of them. There were technically 3 to do, but our goal was tangent of 11 pi over 12. It's not the unit circle. But they told me 11 pi over 12 is the same thing as this, which is the unit circle. And so if you were to write that out and say, hey, I can do it this way, what do you need to know that you're not allowed to do? You can't distribute. Instead, the only way to legally do an exact answer for something not in the unit circle, if it can be rewritten in terms of angles that are in the unit circle, is to know the relationship of the sum and difference formula of tangent. That is the only legal way forward, because tangent does not distribute. And that is why we went and got that formula, and that's why we did all this work, because tangent does not distribute. How the formulas work, you can't, go from a condensed to an expanded if it makes it possible, but otherwise, if you can take an expanded to condensed and it works, it's unit circle, please do that. These formulas are great because sometimes they make a crazy problem simpler. Just sometimes the simpler problem is impossible, so we have to deal with the crazy version. And those are the examples that we did last time. What else did we do last time? What else we did last time was say, hey, we don't even necessarily need to do a sine inverse 5.3 craziness to get ugly angles. Instead, we could also, if they're nice ratios, think about the entire triangles. Using some Pythagorean to plug in what we didn't know, like the 12 or like the 4 for a 3, 4, 5 triangle. If we use the expanded version, we don't have to know the angles. We just have to know the ratios, and if we can plug in all the ratios, we get to avoid the nasty angles that we never needed to know in the first place. Plug in those nice little fractions and say, boom, I got you. You got what? You got the cosine of whatever angle is formed by subtracting whatever those two guys are, and I know nothing about, well, I don't know the angle measure, but I know everything I needed to know if I use my formula. Also, a formula from last time, where we ended was t-proofs. Now, hold on, let's go check out WebAssign. Weren't you there a second ago?
Yeah. Still there.
In WebAssign, still there, go team. In WebAssign, wherever it is, where are you? Did you notice that there were formulas? Anybody who got the formulas right eventually? I heard you got them wrong the first time. Any tips, any tricks you want to pass on and share with the class?
I just put a space between them.
Don't put spaces. Okay, well that's good. They also use parentheses, but I don't think they mark it wrong without parentheses, right?
You just gotta tell the difference between U and V.
Yeah, that's important. That's important. Because something like the sum and difference, remember, co is with or together. Co, sine, but you gotta use the UV, or sine, not with or together. It's not sine, sine, it's sine, cosine, but you need to make sure you switch the variables. Okay, so the first 6 are formulas. Oh, look at number 7. What does number 7 look like? Doesn't it look like it's proving a point about something to do with trig? Don't you have a problem that we literally just did with a sine instead of a cosine that may very well tell you exactly what to do? Use your unit circle. Anybody working on number 7 who does not have number 7 done yet? Exactly. Do it now. You have an example on the board just like it. I'm not going to show you the answer again. I'm going to show you how to do it. Ready, set, go. If you've done number 7, move ahead to number 8. If you've done number 8, move ahead to number 9. If you've done, well, go to the review. I don't care. Be productive. Be productive. The problem is on the screen. This is what you're supposed to be doing for homework. Notes are right there, or Jamboard is right there. Look, it's just like
out my spiral.
unit circle. You have a way that makes sense. We're going to have some samples coming so we can apply what you're still kind of struggling with. And we'll see if that helps provide. Okay. So keep an eye open, Jackson, today for solve. Or if you want, you can like scroll down and find me a solve and be like, let's do this.
Is this number 7 for the?
Well, this isn't the exact. Number 7 for the homework. You have it.
Yeah. Well, I haven't done this one yet.
I think there are cosines and the numbers change, but it's exactly like this. So I'm having you apply the concept to the problem. Yeah. Can you apply it when asked? And as you are doing this, think in your head, are you needing to go to your calculator? Oh! Are you needing to look at the unit circle? Oh! Are you needing, okay, you're not as friendly with the unit circle as we want you to, but do not live in shame. Instead, take a breath and say, I'm going to get stronger. And if worse comes to worse, I'm just going to keep on repeating. If you don't have another way that's sticking, 1, 2, 3, 3, 2, 1, all over 2. Hey, guess what? That doesn't look right. What else do they have?
0.
Oh, square root. That's right. Square root of 1 is 1, so we don't write that. And then counting up. Yeah, counting up, 0. Counting down. Okay, 1, 2, 3, 3, 2, 1, all over 2 with square roots, and we can make it bigger if we want to. Square root of 3 over 3, 1 what? Square root of 3 over 3, 1. Square root of 3. You memorize so many songs without even trying. Listen, you'll have it memorized without even trying. And all you need to know is that this shows you the so, ha, hoa, of your main 3 angles, and if you want, you can expand. Noah. Oh, I could have sworn your hand was up. Are you good?
Oh, yeah.
Oh, yeah. Okay, don't get lost and come right back. Ryan!
So
Oh, sorry, Ryan, and then.
No, it's just like simplify was inside of parentheses for this one. I thought 7 pi over 12 like that was what?
Ooh! Is it a nasty one? Alright, you guys were trying to apply exactly what we just did on number 7, and a classmate has said, but wait, it turns out a little different. Turning out a little different. Well, I think B is still good, because B asks you for two different cosines that you should know. Is it a plus or is it a minus, cool kids?
Plus.
It's a plus. What are those two angles that we're talking about?
Pi over 4 and pi over 3.
And pi over 3? So check it. I could literally say 1, 2, 3. Hey. No, that's sine. 1, 2, 3, 3, 2. Where am I? I'm in the second row. I'm in cosine 3, 2. I'm looking at pi over 4 because it's in the middle. Yay. 1. Yay. Look at me, just using the cheater chart and singing 3, 2, got him, 1, got him, and all I have to do is say, hey, it's root 2 plus 1, and it's kind of awkward. We usually put the 1 in front to make sure it's not in the root. Hey, letter B, we have it done with the unit circle, but what made it harder in letter A when you went to go get common denominators? Common denominators, multiplying by 3 over 3 and 4 over 4. You would have gotten 7 pi over, yikes.
Yes. That is what I was saying. That's 105.
Ready? It is 105. It's still not one that we have memorized in our unit circle. Question, what did we have to do with an over 12? If it ends up being a unit circle, it's great. But if it doesn't end up being a unit circle, we can't use the condensed. We have to use the expanded. So the expanded says, hey, didn't you fill in a formula like this just above in 1 through 6? What is the cosine of a u plus v formula? Oh, because cosine is with or together, and so they're together. The cosine of the u would be the first angle. Cosine of the v would be the second angle. Oh, yay, I can do these. They're unit circle. Pause, though, before I get to the sine part. Question. Will cosine with a c make the sine stay the same or the signs change? Is it a plus or is it a minus?
Minus.
Because it's a C, so it's a changing minus when I have a plus. And then sine of u and sine of v. Boom, there he is, and boom, there he is. Woohoo! And then guess what? Ready? Ready for my cheater chart magic? It's not magic, it's math. 1, 2, 3, 3, 2. There he is. 2. That's the pi over 4 in the middle. Check it out. 1. Hey, that's the pi over 3. Yay, go team. Sine, he's the 1, 2. Oh, he's 2. 3. Oh, he's root 3 over 2. Look at how little mental effort I had to put in.
That was a lot to get to memorizing this.
Oh my goodness. Can you count to 3? Yes. Can you count the other way? Yes. You just got to get it as a habit. Gotta get it as a habit. If you want to, come in and I'll be like, go, and then we'll sing the song and make sure you can write the table, and I'll have you do it again and again and again until it sticks. Chris, does it work? Yeah, it does. Wait, we haven't finished. Ryan, does it work? Root 2 times 1 over 2 times 2 minus root 2 times root 3 is root 6 over 4, and that would be, yeah, it is. I already looked in WebAssign. That's the right answer. Boom, 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 boom. Boom, boom. Andy, go.
Wait, that's supposed to be a 4, right? Sine pi.
Oh, I'm sorry. Yeah, it like stuttered on the thing, didn't it?
Yeah.
Yeah.
Do we have to reduce it?
So,
There is no reducing, actually. The only way to change how it looks, Ryan, would be with a conjugate. Like a root 2 plus root 6. Then I could get some difference of squares things going on. But then you would add in like a radical to the denominator. We don't go that way. Yeah. Ryan, Corian.
so, how did you get the, on the blue font, you wrote the cosine minus the sine?
Oh, it was a plus, wasn't it?
It was a minus. Oh, sorry.
It ended up being a minus, but the original was a plus. I used a formula. And that's why we're doing this troubleshooting together, because you're getting used to new formulas.
So whenever an answer is on the unit circle, you use that formula? Those
If they're asking for a non-decimal answer, so we can't just go to our calculator, right? And it's not a unit circle angle, there must be a way to expand and use a formula. Yes.
You said how distribution doesn't work.
Right.
But does that apply to the other lessons like 5.3 and 5.2?
That just applies to trig anytime you see trig. But 5.3 should not have been asking you to do something like this because we hadn't talked yet about how easy it is for you to go the wrong way. There shouldn't have been plus or minus. There might have been something like the double angle, and we kind of had to like figure out a way, and then it's like, oh, there's an actual formula for you? Yes, please. Like, there might be another way to do some of the problems, but I don't think you guys had a plus or minus in 5.3 inside. If anything, in 5.3, you guys had some like adding and subtracting of a sign plus another sign is 2 sign. You were just combining them. You weren't like dealing with stuff on the inside. Yeah. Where are we? Did that. Wait. We were helping him with a sign, weren't we? Okay, that's number 7. Number 8. Hey, what's number 8 like? Isn't number 8 like the second example that we did? Oh my goodness, she tries to help us. Ready, set, go. Number 8. Yes, I'm literally, go. The example is on the board. The example is meant to help you on number 8. Ready, set, take it away, cool kids. Don't worry, we're not doing this for every single homework problem for those of you that are like, wait. But it's helping people get work done. It's helping them look at the notes and see that I really choose my examples carefully. Asking questions if it doesn't perfectly apply or when something goes a little wonky. We are in the using of the formulas category. Next, we're going to the verifying t-proofs with the new formulas. Then we're going to solve. Ooh, section 5.3, not our favorite. We should see how it applies. And ask questions we're having in 5.3 then. We'll solve with the new formulas. And those are my 3 objectives for today. Can you use them? Can you do t-proofs with them? And can you solve with them? As you're hopefully getting more familiar. I'll be quiet. You guys, go. Number, they got messed up in the algebra or in the solving, and they are writing it maybe different ways than I would write. But do you see in number 9 that they're showing you in degrees an expanded form? Hey guys, sine, sine. Look at your 5.4 formulas. Sine, sine. Who is that? Sine, sine. Sine, sine. Wait, with what? Was it a plus or was it a minus? Minus. Sine, sine. With a minus. Who is that guy? Bring it in. Condense it. 130 is not in the unit circle. 130 is not in the unit circle, but condense it. What happens when you bring it in? This is the exact same formula as cosine. Oh, look, they're showing you. It's cosine of u plus v, which is co minus sine, sine. So you can go backwards and say, oh. So is this the exact same thing as? Cosine of, who is the u? It's the first number. Who is the v? It's the second number. This is going to be the exact same thing as cosine of 140. Well, it's like, okay, neither one gave us unit circle values. So we're not going to be able to know exactly, but it's a whole lot easier for me to think about this as this, the condensed version, than to think about it as this, the expanded version. I can use my formulas 2 ways. I can use it to make expansions when necessary to get little unit circle things I can fill in, or I can use it to make condensing happen if it's either what's asked or what's easier, etc., etc., etc. Those of you guys that are still stuck on number 8, Is there any algebraic simplifying you want me to go over? Which one?
For tan,
Yeah.
we got square root of 3 minus 3 over 3 minus the square root of 3.
Yeah, the simplifying can sometimes get messy, especially in the tangent formula. So remember, tangent of u minus v. But I forget what was negative pi over 12 also equal to? What is that minus? Is it pi over 4 minus pi over 3?
Pi over 6 minus pi over 4.
Pi over 6 minus pi over
4.
Oh, that makes more sense. I was like, wait a minute. Tangent is sine over cosine. Sine is not with or together, so they're separate. Whereas cosine is with or together, so they're together. Cosine, the signs change. Sine, the signs stay the same. That's just my way of remembering it. It's not the best way, but it is a way. If I go and plug in stuff, I could expand this to be tangent of pi over 6 minus tangent of pi over 4 and now it's time for the cheater chart. 1, 2, 3, 3, 2, 1, all over 2. Square root of 3 over 3 is what I'm getting for pi over 6. 1 is what I'm getting for pi over 4. Square root of 3 I'm not using because there's no pi over 3. But I am going to come down here and use again square root of 3 over 3. I just changed keys. 1 square root of 3. Okay, got it. Ryan, you could probably put this in WebAssign and it might mark it right because it looks for the correct answer, not always the most simplified version. But I'm sure that's not what you want to have to type out in WebAssign. And I'm not guaranteeing it'll take it. I'm just saying it is a possibility. The other thing you could do is get thirds everywhere if you don't want to use the trick of multiplying top and bottom by a big fat 3. And I would end up with root 3 minus 3 all over 3 all over 3 plus root 3 all over 3. And when I have fractions, division of fractions is multiplication of reciprocals, which I get some nice reducing that happens. And this would be one way of writing the answer. Could also make it negative 3 plus rad 3, but I don't feel like they would do that. Those are two different binomials. Binomial is the best way to explain it. Two different expressions. I cannot reduce them because they are grouped together and they are different. But let's go check it out. What? Look at them having fun. What did they do? They said there's a square root in that denominator. So good job making it a little bit easier, but you should have, to go all the way, once again, I think they would have accepted it, but to go all the way, they're like, you should not have a square root in the denominator. And so they would have you multiplying by the conjugate like we learned in a previous chapter. That would end up getting you, let's see, 9 minus 3. Square of the first minus square of the last. 9 minus 3 would be 6 over. And if I was to multiply this nasty thing out, that would be 3 rad 3, outer, minus 3, inner, plus 9, last, plus 3 rad 3, which ends up being, this is only, once again, if you're not taking to heart, my reminder that WebAssign does not usually need it fully simplified. So you could have very possibly stopped way back here if you just have the courage, the sneakiness to try to plug it all in. Some calculus kids are loving that this year. 3 plus 3 is 6 rad 3. Negative 3 plus 9 is 6 all over 6. If I divide everything by 6, I get rad 3 plus 2. But that's only if you want to go all the way and not test out WebAssign's, hey, I take unsimplified answers. Maybe that one, maybe this one. You do have 3 chances. Ryan.
So for 9, it only has us like go to where we like simplify the degrees. It doesn't make us like
Perfect. You get to stop at cosine of 140. Dun 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 dun. They were just showing you that. It'd be a lot easier rather than seeing this to just deal with this and a bigger problem. Oh my goodness, so I think I'm supposed to condense this one also and not even just use the formula backwards. And use the formula backward. Well, formula backwards might get me to a unit circle. Triangles. Proving. Solving. I would love to get to numbers 13 and 14, but I realize some of you might be a little bit earlier up. What you should be practicing right now, starting in number 9, is, do you know how to condense? But to be able to condense, you do need to be looking at these formulas unless you have them memorized. To condense, you need to be looking at which one is the one they gave me. I'm allowed to go back as long as I can find the U and find the V, then I can write it all nice and condensed. If you guys are trying, 9, 10, 11, is it 12 also? 9, 10, 11? 9, 10, 11, can you use the formulas backwards? I am here, I am available, 9, 10, and 11. Can you use the formulas backwards? Right, Corey?
I just had a question on
On the tangent still? Or?
yeah.
Uh-oh.
So
I just closed that picture. Can I see your work?
yeah. So I got this, but I messed up because I'm negative here. I thought that because in this equation.
This is right. You know that, right?
Yeah, I fixed it. I put negative because this is so this negative doesn't matter.
oh, it's
What I'm
minus.
trying to do is show you that the formula, why the formula is what it is. The formula, if you use the formula, looking it up and using it, the formula has a 1 plus. So you could have just written down the formula wrong. The formula has a minus on the top and a plus on the bottom. What I was trying to show was how I remember that. And I say that tangent is sine
Yeah, but she's doing it differently.
over cosine, where the sine stay the same for him, and the signs change.
The words like confusing.
Same, change. That's how I remember this. But that's just me having a pattern in the formulas. This is the formula. You plug in the formulas.
Yeah, so this is negative. It's matter.
Incorrect.
If I was to pull up, Michelle, what's up, kiddo? Yeah. You're asking me the why, like why is the formula what it is? Because a squared plus b squared equals c squared. Does the plus, why isn't the plus a minus? That's kind of what you're asking me, like Pythagorean theorem, why isn't the plus a minus?
I just want to know why
I don't know what I'm doing.
the equation, this wasn't a negative, because this is a negative, so
I need
you
to
plug
learn
this
the.
in, like tan B.
I need to
No. If you watch a video, I mean, I guess a teacher might say you could just memorize this one,
Overlapping.
and then you could think of this as that.
Yes.
If you want to think of it that way. But I was not showing you that. I was showing this. I was showing you a different, I wasn't showing you a plus formula, I was showing you a minus formula.
Too close. Can't forget the minus 2 pi n.
And there is a minus formula. So I used the subtraction formula. If you want to use the addition formula, you can. But when you use the addition formula, you're going to have negatives.
I mean, sometimes they throw over 8 in too.
It's not cosine and
Your formula has a plus and has a minus. According to the odd, like you have to remember all these things if you do it that way. You have to remember that tangent is odd, which means it flips the sign. Then you have to come back in here and flip the sign and flip the sign. Or you could just use the other formula. It ends up being the exact same thing. But this would need to go into your tangents. You would need to use the odd property. Then you would need to come in and flip all the signs.
Oh, so it's not negative.
There is a negative, but that was a minus. A negative is a negative is a positive.
That's not a minus.
Not now, because I just changed it.
Oh.
if it was a plus, then you
Number 11.
This is the part. Then you need to go ahead and substitute this in there. And subtraction of a negative will be a plus. And in here, addition of a negative will be a plus. But I think you're trying to make a watch it from some other teacher be the magical way. When I'm trying to very clearly show you, this is probably the simplest version is why are you using a plus with a negative and having to use an odd property when you can just use a minus?
Okay.
Yeah. There's a minus, so you can plug into the minus.
And that works.
This formula expands this expression, which is what the formula works. Yes.
should I just
It's how you spell how you.
We're almost done. Oh my god.
I have heard that maybe, just maybe, some of you guys have been able to, especially with the random conversations that might not be super helpful right now, that you might have made it past all of the whole, hey, let's condense things. And if you made it past the whole, hey, let's condense things, then, hey, let's condense things, the next example in notes, then maybe you're to the triangle thing. And the triangle thing, which I believe is number 12, has an example on the screen, which would be in your notes and would be in the Jamboard. You are not alone, and you don't have to do it like the watch it says. Okay, check it out. You see how the impossible is? Who else is stuck? I'm here. I would love to explain so that the complaining goes less and the empowering is greater.
I need to rewatch all of this.
Just give me something. I get bills. That's what I'm doing. Just give me something. Okay. Is there a formula that has a growth cosine out of the new formula?
Of course.
Yeah, these are symbols.
Sine. Sine.
Or,
Pi.
Just having you recognize what's and then you're gonna take your
You got it right.
No, this one.
Yes, I'll cut some. That's it, right? That's it, sorry. And 4x is the u.
Submit it. You're
Y.
done.
Y
That's
is
called?
b. And then just make it back into the original equation.
And then don't forget your
Make it back for us. Make it-
And then, Natalie, 10 and 11 use the exact same idea. Yeah.
What is that cosine?
Sasha, where's it?
Your shorts on the floor.
Oh, it's under,
D cosine u cosine v plus sine u sine v. What is that cosine?
然后这个就跟这个等于对吧？
Yes, what is the u?
It's never been this hard before.
4x.
It's not even hard, it's just not. This one.
So plug it in.
But
Combine my charges.
it was like hanging weird. It looked like it was like it's a fall in your shirt.
I give you full credit if you get above the 90% of my homework. And so I told Emily that you need to have above 90% of the work shown to get the full point. So you said you didn't do
But what if there's some multiple
this be the
choice?
problem. The question is, what percentage is that? You know what I mean? So give me the section and I'll go look it up real quick. What's the section? Okay. Yes. P.S. Some of our brains are just very young, very distracted. Focus. It's called maturity. That's enough. You got this. What if you're not on the triangle? Can you hear that other kids are? Can you hear that despite an example I did yesterday and it being shown on the screen, if I'm going to go over the triangle one, some people are like, hey, it's not as easy as it looks. If it even looks easy. Can you skip ahead past a tricky problem spot to look at a different problem? Yes, it's called test-taking strategies. You don't just get stuck on one tricky one. You move past it and then come back, right? So we're moving past looking at a triangle problem. The current dilemma that is being seen is that when you plug in, why isn't this working? That's okay, I got you. When you plug in your clues, the ones that I got from right up above, the ones that are in red, I got them right from up here. I went ahead and saw like, hey, I have clues, cool, I have 5 over 13, I'm going to put that in the 5 over 13 spot. Hey, I have negative 3 over 5. I'm going to plug that in the cosine v spot, but don't I still have 2 spots that I'm missing? That only gives me 2 numbers. I need 4 numbers when I expand with my formula. So then I'm showing over here, why do I have triangles on the screen? Pythagorean theorem. I'm taking the 5 over 13 and saying it's an opposite over a hypotenuse of somebody. I'm taking the negative 3 over 5 and saying it's an adjacent over a hypotenuse of somebody. Who's the somebody? It's the triangle. What triangle? The one that I need to fill in what I don't know. So if I want to find what I don't know, which is either the cosine of u or the sine of v, I just need to go to the proper triangle. Okay, u is this guy, because u is that guy. I have 5, I have 13, do a Pythagorean theorem of 13 squared minus 5 squared, and I'm going to end up with 144, and I say, yay, I need you, you're 12. With that 12 adjacent over hypotenuse of 13, I can fill in my unknown. Or, who are you? I need v, and v is over here in this triangle. If I do 25 minus negative 3 squared minus 9, I'm going to get 16. That's going to give me my b is 4. It's in the 3rd quadrant because of a clue that was given. Negative 4, but that's what I'll plug in. So I get to get these unknowns from the triangles that I fill in using some Pythagorean skills. And that work was not clearly shown. So thank you for being like, hey, I can't really tell what happened there. But I used some Pythagorean to fill in what I don't know, to be able to fill in, like, who are you guys? You weren't given to me. No. But I do know stuff about triangles, and I apply the stuff that I know about triangles, which is why it's called the triangle problem. Which is why it's called the triangles problem. Now, as I've been saying for a while now, the goal was to get through number 14, maybe not getting every single one along the way, but at least getting a sampling of not just my examples, which were on the Jamboard since yesterday, most of them, but you're trying a problem similar as well. Take a moment, write down whatever hint or tip or trick you might need from number 12. It's on the Jamboard, but maybe you want to just write down something that I said, like, oh, Pythagorean, or oh, I'm missing, go find, I don't know. But we're going to go look at numbers 13 and 14, because numbers 13 and 14 I have not given great examples for. So I'm going to go ahead and use them as the final two, because I have a T-proof, sure, but that's okay. I can have my plans adjusted a bit, and we can use your homework problems as our T-proof example. And then we can use number 14 as our solving example. Now guys, if anything that we did today was helpful, it might just mean that you applying to T-proofs and then applying to solving. This is 5.2. What's the really nice thing about our little baby quiz tomorrow, which is, well, it's part of a test? You're only dealing with... Yes, I know, play by play. I appreciate it, but we have to focus. 5.2, we're only dealing with 5.2 versions of formulas in the T-proofs you'll have tomorrow. Only 5.2 formulas, not the new crazy ones. And no solving, you're just doing a couple T-proofs tomorrow, okay? But coming back, if we were to go look at number 13, what is it they're asking me to prove? What is it they're asking me to verify? They're asking me to prove this identity, this statement. Now, once again, remember, I know if you just figure out the right fill-in, maybe it took you 3 tries to get there, but you knew it was something to do with trig. That doesn't count as showing work unless you show me the full-on, from beginning to end analysis. Here we go. What do you think? Which do you think I should start with? The left or the right? Are you there with me, number 13? Come on, it's a homework problem. Are you there?
Yes.
The left. Why? Because it's the more complicated. Always start with the more complicated. Question. As we start with the left, remember, you get a point just for showing me what side you chose, and you show me by rewriting it. Look, you chose a side. Cool. You'll get a point tomorrow by drawing a T and choosing a side. Now ask yourself, remember, these are harder formulas, but whatever, we're practicing them. Tomorrow's going to be the easier formulas, like 5.2. For question, does anybody know a formula from what you've been doing in 5.4 or in the future from 5.5 that might apply to this little guy right here? Sine u plus v has a formula that lets me expand, right? The expansion will be sine, not with or together. That's my way of remembering, and the sine stays the same. Cosine. I'm just showing it in blue so that you know I'm plugging into a formula. Do we see that I plugged into a formula? But why am I going to 2 very specific parts of this formula? Why am I highlighting it in red? And why am I drawing a circle that goes around once, and it goes around again, and drawing this little point to say, hey, you're at pi over 2. Is 5 pi over 2 an angle? Can I have it match up to a unit circle, please? And can I look at it and say, hey, I know the cosine and the sine? And all of a sudden I can say, yay, I know the sine, and yay, I know the cosine. Guys, all of a sudden, what happens when you multiply anything by 1? And what happens when you multiply anything by 0? Dun, 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 dun. I think it's easier than some of the 5.2 ones if you understand the formula. And if you're wondering what I did, remember, I had a pi. Nope, that's a 0. I had a 0. I had a pi over 2. I had a 1 pi. I had a 3 pi over 2. I have a 4 pi over 2. And I have a 5 pi over 2. Coterminal angle. I went to what I needed. Like I said, I was not just going to try to get to 13. I was going to try to get to 14. Some of you guys might realize, number 14, there is no plus 2 pi n. Wait, that doesn't have a plus 2 pi n. That doesn't have a plus 2 pi n. Neither does that, neither does that, neither does that. Neither does that, neither does that, neither does that. We're using use our calculator. No plus 2 pi n's in this entire homework. No plus pi n's. No plus pi over 12 n's. You just get to find the set ones they're asking for in one rotation of the unit circle. Uh-huh.
I don't get when you put the plus 2 pi n or like plus pi n.
What I would advise, as far as what to check out, until or unless you can come in and talk to me otherwise, is in your pre-cal, classwork, class resources. We have a shared folder, yeah? Okay. If you go in there, wait, anybody else don't like the plus 2 pi n plus pi over 12n? What the heck is going on? Yesterday, maybe some of you weren't ready for it. Yesterday, we went ahead and talked about number 4 and number 5 that both had plus weird n's. You guys spent some time at the beginning of class doing a warm-up, but I didn't record that. I recorded me solving and me talking through, why isn't this plus 2 pi n? Why isn't this plus 2 pi n? And in the midst of all of this discussion, I was going back to ones that did have, is it right here immediately? I can't find the exact spot, but I went back to the ones that did have plus 2 pi n, and I tried to talk about why wouldn't they write this? Why would they write this instead? It's right here, beginning of yesterday's video, 5.3. We troubleshooted this together. Some of you were here and engaged, and it helped. Some of you needed to get stuck on it on your own. Get back here and try it again. Cool? Or come talk to me. I'd love to help you out. If you want to stay, stay. If you want to go, go. I'm going to go ahead and finish number 14 really quickly for you guys, but Sasha is going to come up and ask a question while I do.
I can wait, so
Are you okay? Yeah.
Hold on.
2, 3, 2, 1, square root 3 over 2, 1, 5,000.
It'll be in the video if someone wants to check it out later as well. Cosine is with or together. Coco.
Put it away, man.
Sine, sine. And the sign changes.
Miss D, when, or you said that we would do something with like adding the 2 pi n to get the infinite amount of like values.
Anything besides
I was getting to a solve one where I thought there would be a plus 2 pi n. It turns out this homework only asks for intervals.
man, it's pretty sad.
And so therefore, as I am currently solving this
That's
one,
what I just said. I said it's pretty
it doesn't address the question I thought it would. So then what I just did
3, 2, 3.
was remind everybody if they can't come in during like a math lab or a period 7 to
Just watch the recording.
remind them where from yesterday we specifically talked about that issue of where is the plus 2 pi n and why is it true. Does that make sense?
Yeah.
And see if that helps. The nice thing is tomorrow has nothing to do with that. As far as it's old section 5.2 before we even did solving. It's just a teacher. But check out the video and see if it helps now that you've gotten to where you're like, oh, this is tricky. Yesterday I told you it was tricky.
Yeah.
It doesn't mean you were engaged. Does that make sense?
Yeah.
And see if that helps. Because that like 45 minutes yesterday, which the video, I think it's only 20 minutes. That was meant to be like, this is hard. Is that cool?
Yeah.
Let me know if that does or doesn't work.
Okay.
Is that cool?
I'm 13.
So quick.
Hey, let's go.
With the teach from each it's at this.
But your formula.
So I found it really easy. But
So right here,
Because now my mom's So I wanted to get into this. Oh, thank you.
Wait, I'm not doing calculus, right? Yeah, he's doing calculus. Okay, I am too. You gotta help me.
which house?
AP.
No, but like ABC.
You guys are doing
Oh, wait, we're
Probably gonna do BC.
Because he already knows all of
can you put in the
it.
worksheet?
Bro, AP is just.
Yeah, right.
On the right side, next to the, on the right portion, the first sign, what's that next to it? No,
I just found a mistake, sorry.
the sign, the first sign on the right side. What's the black? Yeah, what is that? Oh, okay. Thank you.
So in between U, V, and T, does that make
Yeah,
sense?
yeah.
And then,
I have no idea.
and then I can say I have some lecture.
Oh, that was so bad.
I can combine them.
I'm so
Oh my god.
We have a test on Tuesday. We have a test on Tuesday, but we have a game on Monday. So they updated the schedule. We have Friday, Monday, Tuesday,
Thursday and Saturday.
Thursday, Saturday. I know. And then we come back next week for Maranatha and then or Whittier Senior Night.
I know.
Give me a second, kid, okay?
When am I
Thanks, kiddo, I appreciate it.
Like, I don't know what I'm doing.
I know, he keeps on shaking. He's like, you have until
No, can I bring tomorrow?
And like,
You need like 2
This
days.
was the one you were stuck on, right?
simplifying and stuff, and it was
And probably not realizing like, hey, it's just combining like.
yeah.